Alright, so in this video, we're going to be having a look at two different topics. The first one, financial maths and the probability. So let's basically dive right straight into the video so that we can make it short and simple. Alright, so we're going to be starting off with the financial maths questions. So let's read the instruction and then go straight into answering the questions. So the instruction goes as follows here. So Lynn purchases a new car which is worth 350,000 rands. They take out a 6-year loan on the 1st of January 2019. Now the monthly installments are paid at the end of every month. Now the interest is fixed at an 18% per annum compounded monthly. Now here we are given a lot of information there. So firstly, we need to identify, is this a present value or a future value? Now because of the money you get it now, the present tense, right, it means it is a present value. So basically this is going to be PV is equals to 350,000 rands, and then from there, what else do we have here? So we have the number of years. So the period of the year is 6 years, and then from here, what else do we're given the interest. So the interest first, I like to first talk about the compound, because the compound here, it said here it is compounded monthly, so it means 12. Now with the interest they always give you per year, right? So this 18% is per year, but then now because of you're going to be paying monthly, you need to understand how much interest are you being charged, right, per month. So that will be then 18% divided by 12, because you're paying how many times in a year? You're paying 12 times. All right, so now let's go ahead and go into our first question. Now the first question, it says here, let's calculate the monthly repayment. All right, so with the monthly repayment, the first thing that we need to do here is to write the formula. So PV is x into 1 minus 1 plus I to minus n over I. All right, now here, what is it that we're missing here? So here we are asked in this question, or the question is assuming that this person is making all full payments from the time they got the loan up until the very end. So which means here we're still missing to understand what is n. Now n can never be the same. It always changes most of the time depending on the scenario. So in this case, we want to find the monthly repayments that will pay the full amount of the loan. So which means in this case now n will be the number of the years, which is 6, multiplied by the compound, which is 12. So this will then be 72. Now that we know our n, now we need to basically isolate x, because we want to find this value here. So to isolate x, I'll first start by cross multiplying here, and then I have I times PV equals to x into 1 minus 1 plus I to the power of minus n. And then from there, I'll just divide by this 1 minus 1 plus I to the power minus n both sides. Now that way, I can see that x is isolated, and also I don't have to basically go into my calculator spending time typing punching in the all these numbers and then trying to put in what is I times PV and all of that, right? So this one thing here, it gives you one straight answer, and that is why I like to first isolate what I need to solve and then just substitute. So now let's go ahead and substitute here. So I, in this case, it is 18% over 12, right? And then times PV, it is 350,000 rands, so 350,000 rands, and then over into 1 minus 1 plus, again, I here is 18% divided by 12, and then if you remember n, we said it was 72. So now when you press this into a calculator, now this gives you 7,982,73 cents. Now notice that when I pressed it here, in order for you to have this bracket, you need to always make sure that you first put the bracket, and then at the top put the bracket first so that you can have a bracket within the bracket. I don't know if that makes sense. But then now here, this is 7,982, so we need that. So let me write here 7,982, I think. Let me just double check here. Yes, 73 cent, 73 cent, and that is how we basically get our monthly repayments. All right, let's have a look at number 2. Now number 2 says, due to financial difficulty, Lynn misses the 40th payment for the first payment and for the second payment. Now determine the outstanding balance at the end of for the second payment. All right, so now here, what is happening here? So Lynn was paying, everything was fine, and then up until the 39th payment. Then the 40th payment, she missed a payment, and then same as for the first and for the second. All right, now what happens when that happens? Now, because of we working with the banks here, you need to understand that the banks, they're in need for the money, right? So every time when you're not paying them the money, you're basically not paying them the interest that they were expecting from you. Now, what is it that they do? So what they do is that as you are paying, right, they keep deducting the loan, right? They take the interest, they deduct the loan, take the interest, they deduct the loan. So once you get into the part where you miss a payment, what they do is instead of taking that interest and deduct the loan, what they do is they look at what amount was outstanding already. Then from there, they compound that amount, or they make it grow basically by basically charging you for the number of payments that you have missed, right? Then from there, then you get a new outstanding balance that you owe, right? So here, what does this mean now? So it means now here in financial in financial maths, or in a present value, we have a formula that we have that we're using basically to calculate the outstanding balance. But then now I'm going to break it down to you as to how you're going to calculate the outstanding balance, and then from there, how does it then grow into a new balance? Okay. Now here, the formula that we use for the outstanding balance, it is basically P into 1 plus I into the power of M. I'm just going to use M there, and then I'm going to explain what does M mean, right? Minus X into 1 plus I into the power of M minus 1 over I. Okay, so now what does the first formula mean? So this first formula here, what they do again, right, to make sure that they're getting more interest and then they're deducting less from what you owe them, right, what they do is this part, the amount that they've given you, right, this is the PV, right? So the amount that they've given you is they compound it, right? So this is the amount that the loan has grown to, and then this amount here, what they do is they look at the amount that you've been paying to them, right? And then they've calculated everything. So this is the number of payments that you've paid, and then that is how they basically deduct and get how much you have, which is basically outstanding. So this means now these are the payments that you have made, right? So if you're noticing here, this looks like a future value, and then this looks like a compound, because it is like that. It is a difference. It is basically a challenge or a competition between the compound and the future value, right? So now here, because if we're going to be using this formula, how are we going to be using it? So first things first, what we're going to do is we're going to ask ourselves, okay, so as Lynn was paying up until the 39, how much was the outstanding balance that had happened from that, right? Or that had happened there. Okay, so now we know that M here, it means is the number of payments that Lynn has made, right? Or that the bank was expecting Lynn to make. And then this M here, it means it is the number of payments that Lynn has already actually made, right? So now this then means now, because if we know that Lynn has made 39 payment, so it means N here is going to be 39. So the bank has expected her to make 39 payments, so which means she actually did make those 39 payments. So what we need to do now is before the missing payment. This is before the missing payment, right? So let me just write it here. This is before payments were missed. So before payments were missed, right, she had already made 39 payments. So now what we need to understand now is how much was outstanding from there. So now P here will then be 350,000, and then of course 1 plus I is still 18% over 12. Now the bank, before the 48th payment that was missed, bank was expecting that she should have made the 39th payment now, of which that's what the bank has expected. And then from here, this is what we're working on, what Lynn has already paid. So X here basically is 7982,73 into, hope that there's a space here, 18% over 12 into Lynn that time has made 39 payments, so I'm going to put 39 there, over 18% over 12. All right, so now this will give us the outstanding balance. Now let's see what's the answer we get here. All right, so after the 39th payment, the outstanding balance from the loan that Lynn was owing is now 206,000. So I'm going to write it here, 206,000. 584 rand, 584 rand, comma 46 cent. Okay, so 46 cent. Okay, so now this is the amount of the loan that is outstanding now. And then now what happens after? And then what happened was Lynn now missed these three payments. So because of Lynn has missed these three payments, the bank, they cannot actually haven't made any profit from there, right? So what that means is that now, so because of Lynn was missing three, or missed, that's right, missed three payments. What the bank does is they want to come with a new OB, right? So the new outstanding balance, they will then use the compound interest then to see how many payments that Lynn has missed. So in this case here, it is 584.46, right, into 1 plus 18% over 12. Then the payments that have been missed here, because it is the 40th, and then the 41st, and the 42nd, it is 3, so which means here it is going to be 3. Then now we're going to press in the calculator and see what we get for this one. Now pressing this into a calculator, you can see now the amount has grown to 216,020 rand, 90 cent. So now here is going to be 216 and 20 comma 90 cent, and that is basically the outstanding balance that now Lynn is owing to the bank. So now the last question, then it will then ask, if Lynn now decides to make monthly repayments of 10,000, how many will it take her to basically to pay the rest of the loan, right? So now what's happening now is we know that the new loan, or the new present value, or let me write it as new outstanding balance. The new outstanding balance, it is 216,020 and then 90 cent. And then now we understand that now Lynn has decided that, you know what, because if I've missed those three payments, I want to commit to paying 10,000 rands, right? So now how many payments are left now? So how many payments that Lynn still needs to make? Remember earlier, initially we were expecting Lynn to have 72 payments, right? We're expecting Lynn to have 72 payments, so I'm going to write 72 here. And then now we passed 42 payments now, so now we're going on the 43rd one. So which means now I need to subtract this 42 payments with that, and that means now Lynn has 30 payments that she still needs to make. So which means M here is going to be 30. I is still 18% over 12. So now let's go ahead and look into oh no, sorry here, sorry, my bad. Remember here we have the new balance, and then we have how many that how much Lynn is willing to pay, and then we also know the interest. Which is I, which is 18% over 12. And then now we want to find out that from what we have, how many payments, or how many months, right? Because that's what this one is saying. How many months will it take her to pay the rest of the loan? So we want to understand now how many months that are left today that she can basically make the payment, because she's no longer paying that same 9. How much was that? The first one, that's 7,982. She has changed everything completely, so which means we're looking for M, right? So now we're looking for N. Here, not M. M we know is 12, so we're looking for N. So now let's go ahead and calculate for N. So now we're going to use the present value formula. So it's going to be X into 1 minus 1 plus I into the power of minus N over I. So just like how I've done in the previous one, you need to always make sure that you isolate. So to find N here, you're first going to cross multiply. To isolate N, first going to cross multiply like that. And then we have 1 minus 1 plus I into minus N. Then I'll divide by X both sides, because I need to have this part that is N. So I have I times PV over x. Now this becomes 1 minus 1 plus I into minus n. Then I'll take this part to the other side, right? So I'm taking it to the other side, so which means it becomes 1 plus I to the power of minus n, and then this side I have 1, and then I take this one to the other side, then it becomes minus I times PV over x. Now this whole part here, I need to find this power here. So what I'm going to do is I'm going to use the logs, right? So it will be, therefore minus n is equals to log, and then my base here, it is 1 plus I, and then the solution that I have here, it is 1 minus I times PV over x. And then from here, you can basically divide by the negative, and then when you divide by the negative, it becomes minus log into 1 plus I 1 minus I times PV over x. All right, so now let's go ahead and substitute the values and see what we got. So we have 1 plus 18% over 12, and then we have 1 minus 18% there over 12 times what's outstanding. So what's outstanding is 216,020.90 over 10,000, like that. So now let's go ahead and press this into the calculator. All right, so making this, you can see that we have 26,30. So it is going to be 26,30. So now here, these are the number of months that she will pay. So she will have full payments of 10,000 will be made on the on the first 26 months, and then on this the last month, which is the 27th month, then she will make a payment which is less than 10k. So basically this then means now our answer here, it is going to be 27 months, because the question was asking how many months, right? How many months will it take her to pay back the rest of the loan? So now when she makes the 26,10,000 payment, right, doesn't mean that now she has paid all full amount, because there is still that 0.3, which means there's an amount there which is less than 10,000. So that's what this decimal means. So that's it for this part. Now the next part is going to be the probability, where I discuss with you how to do the counting principle. All right, so now let's have a look at the second part of the video, which is the probability. Now the question here goes as follows. Every client of CashSave Bank has a personality identity number, which is a PIN, which is made up of 5 digits chosen from digit 0 to 9. Now, how many PIN can be made if the digits are repeated? All right. So basically with this one, 2.1, we know that if we have 2.1.1, right? So now we have 5 digits, right, that we need to have our PIN, and then we're choosing from 0 to 9. So we know that if we choosing from 0 to 9 and then we're repeating them, so that it means here we're gonna have 10 options to pick numbers from, and then 10 here and 10 here and 10 there. Now when you're looking at this, we're only gonna multiply all these together like that, and then that will be 10 to the power of 5, right? And then the second one will be the digits, if they cannot be repeated, then it means now it's going to be different now, because now the number that you use, you cannot use it twice. So this will then be 10, 9, 8, 7, and 6. And then basically you're going to multiply all of this. With this one, we can say 10, 1, 2, 3, 4, 5. And then with this one, we're just going to press it. Let me just double check if the one that I just write here is correct. Yeah, I made a mistake here. Figured. So basically it's like 100,000 here. And then with this one, it's 10 times 9 times 8 times 7 times 6, then that gives you 30 to 40. And that is how we basically do the first part. Now let's go ahead and look into the second one. Now the second one is the one that I wanted to basically show you, which is the one called not rule, right? It's called the not rule. So let's read the question here and see what it says. So here it says, suppose a pin can be made up by selecting digits at random, and that the digits can be repeated. Okay, now it says here, what is the probability that such pin, right, or such a pin will contain at least 19? Now what is happening here? Now here we're saying here that we have a condition which is an event, right? The event. Now we want to understand what is going to be the probability that our pin can contain at least 19. Now the problem with this is that having the word at least means that the option here, this is the minimum, right? So this is the minimum, and it means there is more, right, of those numbers, because if we're saying that we're having at least 19, where do we then say this 9 needs to be? Does it need to be here, 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 or here, right? So we cannot say for sure. Now this is where the not rule comes in, right? So this is what we call the not rule method that you're supposed to use here. So basically the not rule method works like this. If here we see that here we are given a restriction, and then we're saying we're given at least one, then we see that there's no way we can possibly tell which space or which place should we put in this one. What we need to do here is we need to then ask ourselves that how many ways we can basically put our pin if there is no 9, right? There is no 9 at all. So now here, now in order for that to do, to find this, the first thing is we're going to find the ways, right, when there is no 9, right? So if it is ways where there is no 9, it means now our pin, right, will then be here. We know that there's no 9, right? So it means there's going to be 9 options we're going to pick from. 9 options, 9 options, 9 options, and 9 options. Now this will give you 9 to the power 5. Remember here, this 9 means now we're picking from these digits between 0 to 9. So it means we have 10 digits. If we took out the 9, the number 9, it means we have 9 options left. Hence now these are the 9s. Then now from here, knowing that we have the number of ways where there is no 9, now what we're going to do is we're going to say that if we take the number of ways where there is no 9, and then we add this with the number of ways when there's at least 9. Now this will give us the number of all ways, right? So these always will basically be the one that we had earlier on, right? Now we want the one that says at least 9, right? So now, which means now the number that has at least 9 will then be the number of always subtracting the number of ways that where there's no 9, and in this case it will be 100,000 minus 9 to the power 5. So here we didn't press what 9 to the power 5 is. So 9 to the power 5 gives you 59,000 and 49. So 59,000 and 49. So which means we're going to subtract here 49, and then the total here, let me write it at the top, where there is at least 9, will then be 100,000 subtract 59049, so it should be 40951. Then if you remember, the question wanted us to find the probability, so this was the event, so this is the event, and therefore the probability will then be 40,951 divided by 100,000, and then the answer here will then be take this divided by 100,000, and then it will be 0.41. And that is how we end with this video. And that's it for this video. If you like the video, please make sure that you share this with your friend, and also don't forget to subscribe and leave a comment and tell me how you feel about this video. Also click in there the notification bell so that you won't miss when another video gets uploaded, and I'll see you on to the next video. Cheers.